solving some more equations and finding a solution to a system of equations. But in today's equations, they may not necessarily be solved for y first. So a little bit of action might need to be done to get the equations ready to solve so we can find the solution. So that's kind of what we're concentrating on today. And we're going to do a little bit of that with our first couple of Bell work problems. So in each of these, it says solve for y, state the slope and the y-intercept. Now, hopefully you're getting quite good at this by now. But let's go ahead and do this first one. So we need to rearrange. And if we're going to rearrange, that means we've got to have the y term first. And then the x term will go right behind the equal sign, just like that. So let's rearrange. Negative 5y equals negative 2x plus 10. Remember, when something crosses the equal sign here, it becomes its opposite. So the 2x became negative 2x. Now all we need to do is divide everything in the equation by negative 5 in order to get that negative 5 out of the left side, and then we'll be done. We're ready to go. So y equals negative divided by negative is possible or positive. So 2/5 x. And then 10 divided by negative 5 is negative 2. So there's our first one. Our second one, we rearrange again. We are left with negative 4y equals negative 3x plus 12. Let's divide everything in there by negative 4 to get y alone. So we have y alone here. And then the negatives cancel, leaving us with 3/4 x. And 12 divided by negative 4 is negative 3. All right, so that's a good start on how to solve for y. So we're just kind of a quick review. We know that a system of equations is more than one equation that has x and y in it. So like a couple of linear equations. And when we graph them, we find out that there's an x and y value that's true for both of them at the same time, and that's where they intersect. And so that common point right there is called the solution, and so we're looking for that x and y value for where they intersect each other. We also know that if we have two lines that are parallel, that means that they do not intersect, so they have no solution. If they have one solution, that means they just intersect at one point. And if it turns out that they're the same line when we finally graph them, we notice that one line is on top of the other. That is said to have infinite solutions. All right, here's a couple of equations, and we need to solve these equations for y before we can graph them, and that's going to be the main difference on today's assignment. So let's rearrange. We know that we want to have y equals, the x term is already in its proper spot there, right behind the equal sign. And this plus 4 has to come across and become minus 4. So let's go ahead and graph that. We start at negative 4. 1, 2, 3, 4 on the y-axis. That's the y-intercept. And then the slope says I've got to go down 1 and over 3. So down 1 over 1, 2, 3. Or I can go up 1 and back 1, 2, 3. So my line is going to go right through those points. I'll grab a line tool here, and it'll make it easier to draw a nice straight line. In fact, we better extend that out just a little bit. So if we extend it out a little bit in both directions, then if the intersection happens to be out there a ways, we won't miss it. Okay, now let's look at the second one. Well, the second equation looks to me like it's going to be a little easier to rearrange that. This needs to move to behind the equal sign. So we will have y equals 2x plus 3. So let's graph that one. So we go up to 1, 2, 3 on the y-axis. And then the slope is up 2 over 1, up 2 over 1. But I notice I'm kind of going up away from this other line. So I'm going to try this little trick. I'm going to go down 2 and back 1. Down 2, back 1, down 2, and back 1. And there's my point of intersection. So I get our little line tool again. pull it down through there. We can see our point of intersection right here. So what is that point? Let's mark it nice and bright with red. So that happens to be 1, 2, 3, -3. And then we go down 3, so -3. So two -3s identify that solution. So solve for y, put in slope-intercept form, graph them, and find the solution. All right, there's a couple more. Let's solve the first one for y. Now that's going to be easy on the first one. Just move the x term over, or excuse me, the constant term. We already have the x term over there, so we end up with y equals -x minus 2. So we'll go to -2 on the y-axis, and the slope says go down 1 over 1, down 1 over 1. Grab our straight line ruler, and we put that down through there. Looks like we got to fix that line a little bit, adjust it, so let's get it back down where it belongs. So that should be close enough. All right, let's look at that next one that we need to rearrange. And we're going to end up with y equals the x and the -3 cross the equal sign. X becomes -x, and the -3 becomes +3. So to graph this one, we go up to 1, 2, 3 on the y-axis and make a dot. Then our slope has to go down 1 over 1, down 1 over 1, down 1 over 1. You know, I'm starting to notice something here on this one. These two seem to have a very similar looking slope. And if they have the same slope, that means that they are indeed parallel, which means that they're never going to intersect. So these do not have a point of intersection. So this is one of those special ones where we say that this has no solution. Because they're parallel lines that never intersect. All right, let's move on to the next one. A couple more equations that we need to solve for y. First of all, it looks like we've got a line already over there. We better get that out of there, because we don't want that in our way when it comes time to graph anything. And then once we get this out of the way, we can graph the other two. There we go. Okay, so now let's get these other two going. Okay, so the first one we had to solve for y. Well, it looks like it already is solved for y. Let's take a look at that. So we have y equals, I seem to be stuck in an eraser there. So y equals, these things just need to be switched places with, 6x plus 2. All right, so take a look at that. 6x plus 2. So we can graph it. We can go up to 2 on the x-axis. Now, need to get our pen going here again. Make sure it's got a little bit of technical difficulties here. So we go up to 2. And then we have to, a slope of 6. That's really steep. 1, 2, 3, 4, 5, 6 over 1. We can go down 1, 2, 3, 4, 5, 6, and back 1 as well. All right, then we grab our line tool and grab it here, go up through there, and do just like that. So let's kind of adjust that a little bit, make sure it's nice and accurate. Good. All right, now let's do the next one. So we need to solve that one for y, and so in order to do that, we're going to have -y equals -x plus 3. So now we're going to divide them all by -1. And then when we do that, we end up with y equals x minus 3. So let's graph that one. We go down to 1, 2, -3 on the y-axis, and the slope is up 1 over 1, up 1 over 1, up 1 over 1. And just for fun, I'm going to do down 1 and back 1. Oh, look at that. Grab our straight line tool, drag it down through there, and sure enough, we can see where these two intersect. They intersect right at this point right here, which happens to be at -1, and 1, 2, 3, 4, -4, -1, -4. So that's the idea. So we've got one more example, and then we're ready to go. So on this example, first one, we need to move the 6 to the other side, so we end up with 2y equals negative, and I'm going to go ahead and put a 1 in there, -1x minus 6, because we need to know there is a 1 there. Then we're going to divide everything by 2. And when we do that, we end up with, I'm going to move it up here, y equals -1/2 x minus 3. Let's go ahead and solve this other one first. Divide everything by 4. And remember, there's a 1 in front of that x as well. So when we divide everything by 4, we end up with y equals 1/4 x plus 1. So let's graph the second one first. So we start at +1 on the y-axis. Then we go up 1 and over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Grab our line tool and stretch it through there. And just extend it a little bit in the other direction. Oops. Extend it drag down through there. So down 1 and back 4. That should be good enough. Now let's look at our first equation that we had. We'll actually graph that in a different color. We'll graph that in red. So it had a y-intercept of, actually we'll graph it in another color because we're already using red. We'll do it in orange. Okay, so, all right, now let's get our different color. So we go down to -3, 1, 2, 3. And then our slope says we'll go down 1 over 2. Down 1 over 2. I can see we're kind of moving away from the line. Unless we go up 1, back 2, up 1, back 2, up 1, back 2. And so the question is, where does this cross? And it looks to me like this one we've kind of gotten a little bit crooked. So let's get this line back where it belongs. Let's just see. So the question is, where are these two going to intersect? And it looks to me like, boy, it's kind of hard to tell, isn't it? See that, how it's kind of hard to tell? We've got a slope on this one of down 1. This one's got a slope of up 1 over 4. There we go. Down 1, 1, 2, 3, 4. That's our problem right there. Okay. Now let's get a line tool on that last one in there. See if that will help us, because if you don't have a nice accurate line, sometimes it's hard to tell. Okay, so that one looks like it crosses right there, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5. Oops. We got to get the right tool here. -5.5. And then that's only down about 0.5, -0.5. That appears to be about where these two are crossing. So what we're seeing then is there is a limitation to what kind of accuracy you can get with a graph. And so we're going to, after this assignment, we're actually going to show you some other ways to do these. But for today, we just have a worksheet for you to do. Thank you very much.